Hi, I'm Mark. I'm not an electronics engineer, but I've seen one on TV. Today, I'll be talking to you about the Multicomp MP7511 Arbitrary Waveform Generator. Yeah, this little thing right here. And it can do almost anything. Can almost do anything. This little guy right here is made to make signals and send them out into the world. And I've got a pretty neat demo that'll walk you through that in just a minute. But before we do that, let's take a closer look. The Multicomp MP750511 Arbitrary Waveform Generator looks a whole lot like something else out there from Owen. And there's a good reason for that. I'm pretty sure it's the same tool. It's got all the bells and whistles that you might expect for a 60 megahertz, entry-level bit of kit. There's other products in this line that go all the way up to 100 megahertz, maybe beyond. Scientists have been trying to determine that question for ages. It's got 2 channels, and it can output all sorts of your typical test equipment waves, sine waves, square waves, triangle, sawtooth, pulses, just about any bit of noise that you might expect. And you can also program your own peaks and valleys using their included software, which is kind of fun. Pop open this box. This was sent to me by E14. Just want to make sure that's out there. We'll see what's in there first. I bet you it's a big fat stack of cash. It is not a big fat stack of cash. That disappoints me. We've got a power cord, a couple B and C, I assume 50 ohm USB power cord. We've also got what appears to be a Multicomp branded coaster, and looks like a specification sheet and a small user manual. The device comes packaged in pressed pulp protectors and a little styrofoam bag thingy. The first thing I think I'll like to do is get this thing hooked up to USB to see if we can control it through SCPI commands. So that'll be our first job, and then if we can't do the USB, we'll move over to the RJ45, the network jack. The only way to install the USB drivers is by lowering the security level on your system to allow unsigned drivers on your system. That's not something I was willing to do. So I've got to go back and look at the network option. We just need power and a Cat6 or a Cat5 cable. Then we'll just give this bad boy a chance to power on. We'll have to figure out what the IP address of the device is and load some Python. So I want to go to Utility and IO Setup Network Setting. So the first thing I'm going to do is just make sure that it is indeed at that address, or at least there's something at that address. If not, I've got to do some network troubleshooting, and it's there. All right, so next up, I'm going to head over to a folder that I'm creating for these experiments. And there, I've already created a virtual environment, but if you've never done that before, it's pretty simple in Python. You are just calling the virtual environment module, and you're giving it a location to exist. This lets you install things. In this case, I installed PyVisa, but it's already there. But that's all you have to do. And if you're not sure how to do that, it's documented in Python. The basic idea is that you don't start installing all of these custom modules over your base installation, entering that virtual environment, going to the scripts directory, and activating it. So now we are in a virtual environment where I've installed the module PyVisa. I've got 2 windows here to type in. The first one has the PDF of all of the SCPI commands, and the second one is my PowerShell, where I am in my virtual environment. And we're just going to play around and see if we can't figure out frequency command. So we'll take advantage of that in just a second. But first, let's go to the PyVisa shell. We've got to open a resource, which in this case is a TCP IP port 192.168.2.70, port 3000, and we have to tell it that we're going to use that socket. We've now opened that, and we should be able to check it by saying query IDN and seeing if we get anything back. And if we don't, it's an end of line error. So you can hit this and it'll tell you all the different commands. In this case, we need to change our term character. And we're going to turn on carriage return and line feed. And now we should be able to query IDN. Whoop. Asking it to identify itself, and it does. So we can talk to this now. So that's certainly exciting. All right. So I'm going to say source. I'm going to say write to source 1. I want to set a frequency. It's going to be a fixed frequency. And I'm going to say, make it 20 hertz. And then we're going to query it, and it's set to 20 hertz. Life is good. Now we should be able to hook something up. And for that, I brought my friend the speaker box. And what I did was laser cut a box, and I put a speaker in it. I know it sounds pretty complicated. I do have a degree in physics, if that makes any difference. But yeah, that's speaker in a box. You don't actually need it in a box. But what does help is if you do one of these numbers. You could 3D print it. In this case, I laser cut a little circle with a hole in it so I could pass a string through to make a vibrating wave. All right? It's a little lot of fun. That technical term. So anyways, we're going to take that and we're going to hook it up. Now, what we need to know is how to turn this thing on. So I'm going to go back to the beginning here and look at the commands again and see if I can't find an output. Output 1, state, and then on. There we go. And you can probably hear it, but I don't think that you can see it moving yet. That might be, in fact, too fast. So what else can we do with these bad boys? Well, the other thing that we can control is a laser. I don't have one on me. I'm going to have to grab a laser. All right, it wasn't easy, but I found a laser. Had to wrestle a shark for it. So off screen, I have a 5-volt power supply hooked up. So we're going to hook up the signal, but we're not going to turn it on. We're going to turn on the laser. As a neat little trick, if you ever want to spread out a laser, put a glass rod in the middle. Check out that line. So if you're careful about where you arrange this thing, you can turn a single diode laser into a line laser, which is pretty neat. Our job is to create a modulated signal. Okay, we'll probably have to set the amplitude and we'll have to do other things, but we're in the point now where it doesn't really make sense to stay in PyVisa. We've got too much going on. We're going to make a Python file. You excited? I know I am. Do I have Notepad++? I do not. How about Notepad? Yay! Well, it's something. We've got a Notepad open where we can type stuff, or maybe you do know how to write Python files, in which case this isn't much of a big deal for you. Maybe you don't. But I'm going to teach all those of you that don't a trick, and that is something called ChatGPT. 3.5 is probably good enough to get you there, but 4 is even a little bit better. Write a Python file that uses SCPI commands to operate an arbitrary waveform generator in constant frequency mode on 2 channels. And again, I installed VISA previously, but we're going to import the PyVisa library. No problem there. I was just using it, so I know it works. We're going to create a variable called RM, and that's going to be assigned to the PyVisa resource manual manager. Then that variable, we're going to start opening resources, and you'll notice that line is something that we did earlier. It'll start by resetting the instrument. These values here, we're probably going to have to change, but it at least gets us a good start on what it is that we want to do. The first thing we're going to do is change our IP address and our port. So this first thing that it's doing is resetting the instrument. I'm fine with that. Now, here's where it's probably not going to work. We use different functions, as I'm sure you remember from a few minutes ago. These commands just aren't commands that are going to do anything for us. Let's go back and we remember the output state, right? Then if we go back to our frequency command, let's get back up here. We can modify those statements. We want frequency fixed. So I am just going to change what those things say. And let me actually see if I can make this a little bigger for you. Let's go back. There we go. You guys should be able to see that. We do need to check that, but we'll do that in a moment. Source 1, frequency fixed, and I'm going to set that to 60 hertz. I'm going to say source 2, and I'm going to do the exact same thing. All right, so this is our first Python file with the help of ChatGPT. It got us a lot closer. Didn't get us all the way there this time, but I've had it in the past just nail it. All you'd have to do is change the IP address. So we're going to import the PyVisa library. We're going to use PyVisa and the resource manager function right here to create this variable rm. We're going to create a new variable instrument, which is opening this resource. And then we can start writing commands to it. We do need to check reset here. So let's look for RST and see if we have anything. It looks like there's a star reset on page 14. 14, reset no query form. It just resets it to its factory defaults. All right, we've got a file. I'm going to save this in Multicomp Waveform Generator, and I'm going to call this trial01. We've got that open. So now over here in Python, I should be able to see that. I want that speaker bouncing up and down and thumping. So we can do this. I've hooked up a string to the speaker to the AWG. I also hooked up the laser to the AWG. And by timing things almost exactly with the shutter rate of the camera, I'm able to capture and freeze waves. We've got a laser and a speaker, and you too can go make that cool little experiment that I just showed you. Well, I hope you had fun with the Multicomp AWG. This particular product number is the MP750511, and it's a very good introductory AWG. It's got a ton of functions, and it's probably going to be right for your lab, unless you're doing something that requires you to have a $10,000 function generator. I think this one's going to be okay for you. I hope you've enjoyed it. I'm Mark, and this is for Element 14.